Today we're going to be reviewing factoring by grouping. So we've gone over how to factor out the greatest common factor from an expression, but today we're going to be looking at expressions that don't have the same common factors all the way through. So if we take a look at this first example that we're going to go through in just a moment, if I try to factor out the same exact factor from every single term, I'm not going to be able to do that. These first two have a 2 and a u in common. I can divide a 2 out of 2 and 6 and a u out of both terms. If I try to come to these last two terms, I cannot divide a 2 out of 5 evenly or out of 15. So these two have a common factor, but the second two terms don't have the same common factors. But if we look at these two terms together, they are both divisible by 5. So this second part also has a common factor that I can divide out. So when this happens, we're going to be using the methods to factor by grouping to get our polynomial factored. So our first step is going to be to group the terms with common factors, which if we look over here, we just did that. And then our second step is going to be to factor the GCF. So we're still following the same exact steps to factor. The only difference is that we're going to have to do it twice with this type of problem. After that, after we're done factoring both of those parts of the expression or the polynomial, then I'm going to use the distributive property to group the factors together. If we do this correctly, when we're done factoring, we should have the same leftover expression inside of my parentheses. We also talked about special products, so we're going to see some special products of difference of squares today, which are always going to be written in this format. Anytime you have a perfect square subtracted by another perfect square, that's going to be written in this format because it's a difference of squares problem. So we're going to go ahead and factor that first expression or polynomial over here on the side. We already grouped our factors, so now we're going to use our factoring method to go ahead and get the GCF pulled out. I'm going to use the ladder method. You can use whatever method is your favorite method. I'm just going to do my upside down division symbol. I'm going to factor that first part, and then I'll factor the second part. So like we already discussed, 2 can go into 2 and 6, so that's going to be my first common factor that I pull out. 2uv divided by 2 just gives me uv left over, and then 6u divided by 2 gives me 3u left over. So now they don't have any common numbers, but they do have common variables, so I'm going to go ahead and divide out the u from both of those terms. uv divided by u gives me v left over, and 3u divided by u gives me 3 left over. So if we look at that leftover expression, they don't have any factors in common, so this is our GCF. Remember, GCFs go outside the parentheses, and our leftover factors that didn't have common factors go inside. So we're going to go ahead and do that with the second part of our polynomial. They both have a 5 in common, so I'm going to divide out a 5. 5v divided by 5 is v, and 15 divided by 5 is 3. So again, we don't have any common factors left, so that is our GCF. And then if we do this correctly every time, we should have the same factor left over in the parentheses. So that factor that was left over is going to be one of our factors of our expression, and our GCFs that we pulled out are going to be our other factor. So this is our factored expression. We can always check to make sure that we did this correctly by multiplying out. I can use the box method and multiply this first factor by the second factor, and it should get me back to my original expression. When I multiply this together, if I don't get my original expression, then we need to check to make sure we didn't make a mistake. Okay, so I'm going to go ahead and do number 1 with you as well. So again, we're going to start by checking to see if there's a GCF that I can divide out of every term. If I can, then I'm going to factor it normally, but if I can't, I'm going to look to see if I can factor by grouping. So this first term has 21m. The second term also has an m, and it has a 3, so 3 can go into 3 and 21, so those have common factors. Moving on to this third factor, this third term, 3 can't go into 4 evenly, and m can't go into p. And there is no m term here. So 21 and m and 3mp have common factors, but this 4p doesn't. So we're going to move over to this last term and see if our 4p and 28 also have a common factor. So 4 can go into 4 and 28, so I'm going to go ahead and group those together as having common factors. Okay, I'm going to go ahead and factor those normally and pull out the common factors that we already discussed. And that's our GCF on the left, our leftover factor on the right. Then we're going to go ahead and move over to the second part of our polynomial and factor out that 4. So 4 would be our GCF. So now when we have our factors written out, 3m and 4 are on the outside, and 7 minus p is on the inside of this first one. So we've got to be careful with this, because if we take a closer look, the p is negative here, but in this one, the 7 is negative. So what we're going to do is we're going to factor out that negative symbol that's on our p here, because I need my p to be positive and my 7 to be negative. So I'm going to divide a negative 1 out, and that's going to turn my p positive, my 7 negative. So I factored out or divided by a negative 1 because my factors in my parentheses need to match. Okay, so I'm going to go ahead and rewrite my factors. I've got 3m and a plus 4 for our first factor. And for our second factor, I have a positive p and a negative 7. And again, we can check by multiplying through. So I want you guys to go ahead and try out 2 and 3 for your try it problems and enter those into the formative. And then we're going to talk about difference of squares. So each one of these below is a difference of squares problem, because we've got a perfect square minus another perfect square. So each one of these on the bottom row is going to be a difference of squares. So we're just practicing setting up that format. Every time you have a perfect square minus another perfect square, it's going to be a difference of squares. So our factors are going to be a plus and a minus. And it's going to be the square root of the first term and the square root of the second term. So the square root of x squared is just x, and the square root of 1 is just 1. So that would be our factored expression using difference of squares. Sorry, 1 second. Formatting got a little messed up. All right, moving over to that to number 5, because I'm going to have you guys do number 6 on your own. We're going to do another practice problem for difference of squares. So again, we have a perfect square here, because we have 2 times 2 would give me 4, x times x would give me x squared. And then we have a perfect square here, because 9 times 9 is 81, and y times y is y squared. So since this is a difference of squares as well, I'm going to have a plus minus, and then I'm going to take the square root of the first term and the square root of the second term. So like we just said, the square root of the first term is 2x, and the square root of the second term is 9y. Okay, so go ahead and try out 2, 3, and 4, and make sure you finish the formative.